Welcome back. Today we're going to be talking both about frequency tables and about relative frequency tables. So first of all, a two-way frequency table is, it deals with frequency, or how often an event occurs or how many times an event occurs. And a two-way frequency table is data that's been categorized by in two ways. So the rows indicate one categorization. So if you look here, these are people who have a bike and people who do not have a bike. And the columns are a different categorization, people who go to the farmer's market and people who do not go to the farmer's market. Okay, so there's two different categorizations here. Sometimes you will see a frequency table that has three categorizations on top and two on the side, but I think we're going to be dealing just with two-way frequency tables today. Okay, so a poll in 120 town residents found that 40% owned a bicycle. Of those who owned a bicycle, 75% shopped at the farmer's market. And of those who did not own a bicycle, 25% shopped at the farmer's market. So we're going to use this information and fill this into the table. Now, the first thing that you should understand is that each individual, so remember, a row is going horizontally and a column is going vertically. And you can remember that because columns in buildings are vertical pillars. Going down from the top of the building to the bottom. So I always remember them that they're vertical, right? And each individual space right here is called a cell, right? So a cell. Okay, and a cell right here indicates this is the frequency of people who are both going to the farmer's market and own a bicycle. Whereas right here, this is a row total, right? It's the end of the row. So this row total indicates how many people own a bicycle, for instance. And this one would be how many people do not own a bicycle. This one would be how many people go to the farmer's market, and this one would be how many people do not go to the farmer's market. And this right here is the total. This is always the total of everyone's survey. So that's 120 people. So out of 120 people, they found that 40 owned a bicycle. So in order to fill this out, we have to figure out what 40% of 120 is. So we're going to do 40% times 120. Well, 40% is just 0.4 as a decimal times 120 gets you 48. So there are 48 people here. Now, in order to figure out this right here, so everyone who's been in this survey either owns a bike or does not own a bike. So to get this other part here, I would take 120 and subtract 48, and I would get 72, right? So 72 I got from taking 48 from 120. All right. Okay, so let me see if I can fill in any more here. Of those who own a bicycle, so out of the people who own a bike, right, so people in this category, 75% of them shop at the farmer's market. So notice that before they said that 40% of the 120 owns a bicycle. But here they're saying out of people who own a bike, which is only 48 people, 75% of those people out of the 48 people shop at the farmer's market. So here I have to figure out 75% or 0.75 times 48, not times 120, because they've already given us this qualification that it's only the people who own a bike. 75% of them go to the farmer's market. So here that's going to be 36 people. I already calculated that. 30. Okay, that means that this has to be 12 here because it adds to 48. Let's see, we can't get, if two things are missing in a column, then we can't figure out what they are. Let's see if there's any more information. Okay, of those who did not own a bike, 25% shop at the farmer's market. So we want to get 0.25 times 72, and that's going to be the people who shop at the farmer's market, and that's going to be 22 people here. Okay, so we know that this plus this is 72, so this must be, this is actually 18 people. That should be 18. And that makes sense because half of 72 is 36 and then half of that is 18. Okay, so this is 18 people and that leaves this one to be 54. Okay, and then we can add these two together to get 66. Those are the people who did not go to the farmer's market, and add these together to get 54. Those are the people who did go to the farmer's market. So we have 120 people total. So we get 120 if we add these two right here, and we have 120 if we add these two people. Okay, so out of the people who own a bike and don't own a bike, that's 120 people. The people who go to the farmer's market and don't go to the farmer's market, that's 120 people as well. Okay, another thing that we do with these two-way tables is we create frequencies. So instead of a relative frequency. So relative frequency is beyond just a frequency is where we write down the amount of times something occurred. A relative frequency is relative means that we look at out of the total how often is it occurring. So in these ones, if I just said, well, 36 people owned a bike and went to the farmer's market, and I didn't tell you the total, that doesn't give you a very good understanding of the percentage of people overall who both own a bike and go to the farmer's market. So what I do here to create a relative frequency is I divide the number of objects here in the cell by the total to get a relative frequency. So for instance, the frequency table below shows the results of a survey that Maria took at school. So it looks like she's asking people who owned a cat, a dog, or other as pets. She has 50 randomly selected students whether they prefer dogs, cats, or other pets. So I guess this is preference, it's not owning. Convert this table to a relative frequency table that uses decimals as well as the one that uses percents. So here, what we did was, if she wanted to figure out the percentage of people who preferred a dog, then she took 22, which is the people who preferred that, out of the total. So she divided 22 by 50 to get 0.44, and that's equal to 44%. So we can say 44% of people preferred a dog. For cat, we would take 15 out of 50, and that would be equal to, that's equal to 0.3. or 0.30, which is 30%. Remember, from a decimal to a percentage, you multiply by 100 or move the place value 2 places to the right. And then we do 13 out of 50, and we would get 0.26 here, and that would be equal to that's 26%. Okay? And the total would be 50 people out of 50 people, and that's of course 100%. Right? So this is how we get relative frequency. Now, there is, I made a mistake here. I said own instead of preferred. I didn't read very carefully here. We'll get to that in just a second. So there's two types of frequencies that we're going to talk about on this slide, and then a third on the next slide. So there's joint frequency and relative frequency. So it looked like in the last slide we only had a column of her table here. Now she's categorizing the people in her survey by two ways. She has 3 ways on top and then 2 ways on the side. So dog, cat, other, and girl and boy. So the results are shown in a 2-way frequency table below. Each entry is the frequency of students who prefer a certain pet and a certain gender. For instance, 10 girls prefer dogs as pets. So we're supposed to complete the table. Well, this is fairly easy to do because we know that we add these two together to get 22, and that's the total people who said they prefer dogs. Cats was 15. This was 13. If we add across, we would get 22, and then 28, and we can see together this is 50. So if I add these two together, I get 50, and if I add across, I get 50, right? And I guess what we had before was we had the column, the last row, rather. We had this last row. So she took this last row and she identified the girls versus the boys. Okay, so a joint relative frequency is found by dividing a cell frequency by the total. So for instance, if I ask you the question, what percentage of people who were surveyed are girls who own or who prefer cats? Okay, so what percentage of people are in this basically right here? So 9 people were both girls and prefer cats. So we want to take 9, and notice that I am looking for the percentage of overall people surveyed who are both girls and prefer cats. So I'm taking 9 and dividing it by 50. Well, 9 divided by 50 is going to be equal to 0.18 or 18%. So 18% of girls preferred cats. Now, a marginal relative frequency, so this is right here, is found by dividing a row total. Now let me highlight the row totals here. The row totals are here. They're the total at the end of each row. Or a column total. So a column total would be here. These are the column totals. So this is a marginal relative frequency. It's found by dividing one of these numbers by the grand total. So if I asked a question like, how many, I need my pen back, how many, what percentage of people surveyed, so out of the 50 people, how many of them were girls? So to get girls, I would have to get a row total, right? Because that's the categorization along the rows. So we'd say 22 out of 50 people were girls, and that is, let's see, I calculated that previously. It was 0.44 or 44%, okay? And how many people who were surveyed own dogs? Well, to get, preferred, that would be 22 out of 50 again. So 22 out of 50 was that 0.44 or 44%. Okay. So basically what changes between marginal and joint frequency is that this category of owning dogs is either a column total or a row total, whereas with joint it's just a cell total. Okay. And I remember it marginal versus joint because margins are the things on the side, like if margins of a paper are on the side or on the bottom, right? So I always think that these are the numbers that I'm taking from either the side or the bottom, whereas the joint, I remember it like a joint, like an elbow joint, right? Where my elbow is the intersection of this part of my arm and this part of my arm. So a joint is just one single cell, which is the intersection of both a row and a column over the total. That's how I can remember it. Now, a conditional relative frequency is the next category. Now, the way that you get this is dividing a cell frequency by a row total or a row column. What's different about this is that we're no longer using the total here to divide by, like we did in all of these examples. We are using the row total or the column total. So for instance, this could be a question like, what percentage of boys own a pet other than a cat or a dog? Okay, so what percentage of boys, so out of all the boys, so this is, I have to just, there's 28 boys. How many of them prefer, this should be the word prefer something other than a cat or a dog? Well, that would be 10 out of 28, which would be equal to, let's see, 10 divided by 28 is, and this one I'm actually going to have to round here. So this one's 0.357 if I round to the nearest thousandth, which is approximately equal to 35.7%. And again, the difference between this one is you're taking a cell and you're dividing it by one of the numbers along the margins. Okay? Okay, now relative frequencies, all three of the ones that we just saw, can be used to answer certain questions, like whether or not there's an association between one categorization and another categorization. So this next situation will help us figure out if there's an association between teens who have curfews and those who do chores. So out of 100 teens polled, whether they were required to do chores and whether they had a curfew, this is the result of this poll. All right, are teens who have a curfew more likely to do chores than teens who do not have a curfew? So this is my question. Is there an association between having a curfew and doing chores? So what I want to figure out is I'm actually going to calculate a conditional frequency, which is taking a cell total and dividing it by either a row or column total. So out of the teens who have a curfew, how many of them have so out of the teens who have a curfew, how many of them do chores? So that would be 16 out of 32 or 0.5 or 50%. So 50% of students or of teens who have a curfew also do chores. All right. Now let's figure out of the teens who do not have a curfew, that's 68, how many of them do chores? So we have 4 out of 68. And that's going to be equal to 4 divided by 68 is approximately 0.06, and that's 6%. So it's more likely for teens who have curfews to also do chores, as opposed to teens who do not have a curfew. It's less likely for them to also do chores. All right, let's try our hand at one last question. So data from 200 flights were collected. It was categorized that all the flights were categorized as late or not late, or domestic or international. All right, is there an association between international flights and being late? So what we're going to again look at is the conditional frequency. So out of all the domestic flights here, which is 150, how many of them were late? So we need 30 out of 150, and that's going to be equal to 3 out of 15, which is 1 over 5, which is 0.2 or 20%. Okay. Out of all the international flights, 10 of them were late. So that was 10 out of 50, which again is 1/5, 0.2 or 20%. So it looks like there is not an association for international flights and lateness, because both international and domestic flights are 20% late and 80% on time. Okay, so in one we found that there was an association between having a curfew and having chores, and the other one we found there wasn't an association between having being on a domestic flight and having and being late. All right, and that's the end of the lesson for today.